In section 3 here of sequences and series, we are going to talk about a few different topics. The first one being infinite geometric series. Now, there's some things you need to know, and I have these on your blue reference sheet. We're going to first talk about if a geometric series converges or diverges when we're talking about an infinite geometric series. If it converges, right here, it has a sum. If it diverges, it has no sum. And that is all based on this fact right here, which I have on your blue reference sheet. An infinite geometric series has a sum if r is between -1 and 1. So I looked at writing it as an inequality too. So if r is in between -1 and 1. If it's bigger than 1, it does not have a sum. If it's smaller than -1, it does not have a sum. Now, r is found the same way you found it for just regular geometric sequences and series. You take a term and divide by the term in front of it. Okay, and then there will be a formula down here if it does have a sum. If r fits those requirements, here's your formula, which I have on the reference sheet. And this stands for the sum of the infinite geometric series. That's the infinite symbol. And it's actually a real short formula, much shorter than the ones you were dealing with in the last section. It's just a1 over 1 minus r. So basically on the first section here, you're just determining if it converges or diverges, if it has a sum or if it doesn't have a sum. So if you look at number 1, that's the first one we'll look at. a1 is 4, r is -3. Well, r is smaller, it doesn't fit the bill of being between -1 and 1, so it has no sum, which means it diverges. So that's the word we want to use. If you look at number 2, r is 0.8, so that is between -1 and 1, so it has a sum, which means it converges. Now, a couple other comments about this top section here. You're not actually finding the sum. For instance, on these problems right here, you're going to have to figure out r by taking a term divided by the term in front of it. And remember, when we're dealing with sigma notation, now you can notice these are infinite geometric series by the infinity symbol on top of the sigma notation. But remember, in all of these, this is a1 and this is r. So you got to kind of look at what r is. Okay, so let's look down here at number 13, where we're actually going to do some calculating. Evaluate each infinite geometric series described. If it does not have a sum, you just need to state that down here when they're asking you to evaluate or calculate the infinite geometric series. So if you notice on 13, we still have to think about, does it have a sum or does it not? Does it converge or does it diverge? And it's all based on r. And r is -1/2, so that tells me it does have a sum. So it has a sum or it converges. And that is found, again, by this formula right here. The sum of the infinite geometric series equals a1, which is -16, all over 1 minus r, which is -1/2. Now, if you simplify this, we get -16 on top. This turns into plus. 1 plus 1/2 is 1.5 or 3/2. I'm going to write it as a mixed number. When we're dividing by a fraction, you have to remember the rule. That means multiply by the reciprocal. So I'm actually going to multiply by 2/3. So I'm taking -16 times 2/3. So that's -16 over 1 times 2/3, which would equal -16 times 2 on the top is -32 over 1 times 3, which is 3. And I'm just going to leave it as an improper fraction. You could write it as a mixed number. That would be -10 and 2/3.